So we're looking at example 5 next. And example 5 wants us to figure out what's the limit as x approaches 1 of 1 over x minus 1 minus 2 over x squared minus 1. We put 1 in. 1's going to cause division by 0, so there'll be an asymptote there, so it'll be approaching infinities there. And if we put 1 in down here, 1 squared is 1, 1 minus 1 is 0. That's going to create a second asymptote there, so it'll be approaching infinities there. So this has form infinity over infinity. So what we're going to do is algebraically we're going to try to clean this up. So we'll look at 1 over x minus 1 minus 2 over x squared minus 1. We'll note that this 2 over x squared minus 1, that factors as x plus 1 times x minus 1. So this bottom part here is actually this. So if we wanted to make these have the same LCD, this has an x minus 1 in it. So we could multiply it by an x plus 1 over an x plus 1. And that would give us x plus 1 over x minus 1 times x plus 1. All that minus 2 over x minus 1 times x plus 1. So now that these have the same LCD, we can add them together and get x plus 1 minus 2, all that over x minus 1 times x plus 1. Plus 1 minus 2 is minus 1, so this is x minus 1, all that over x minus 1 times x plus 1. So the x minus 1s can cancel, and we're left with a 1 over an x plus 1. And this will hold, since x minus 1s are 0 at x equals 1, this will hold as long as x wasn't equal to 1. So if we think about that, this is saying that the original statement, this original subtraction here, is equal to this as long as the x's aren't equal to 1. Well, luckily the limit we're looking at is 1. So when we can say that this expression here is equal to the limit as x approaches 1 of 1 over x plus 1. 1 over x plus 1 is an elementary function. It's continuous everywhere except where division by 0 happens. So this is continuous everywhere except for at -1. Positive 1 is not -1, so this is continuous there at x equals 1. So this is continuous at x equals 1. So therefore we can evaluate it using substitution. We can substitute our 1 in for the x and get 1 over 1 plus 1 is 1/2. And stop there.